Hi, everybody. Welcome back to Shiko Math Practice Lab. And today, this video, we are try to practice L'Hopital's rule. And this is our practice set number 3. And we are going to work on the form. You see infinity over infinities here. So here is the set of the problems we are going to practice. And we have 10 problems. So we probably will divide it into 2 parts so we don't go too long for one video. Okay, so as always, you can pause the video and copy down the practice problems and then the practice by yourself first. And then after you finish, then resume the videos and we can check the answers. And okay, go ahead. If you want to go ahead and pause the video and try to do the problem by yourself first. And I'm going to go to the whiteboard. Hi, everybody. I'm back. And I hope you do have a chance to practice some of the problems I listed there. And remember, practicing is the way to make you getting better in the math. Okay, so before we start this practice problems here, let's take a look. Let's do a brief review about what we learned about the L'Hopital's rule. So we said the L'Hopital's rule is dealing with the indeterminate form, 0 over 0 and infinity over infinity. Those are the two very basic indeterminate form. And so we did our previous practice set, number 2. We're dealing with the 0 over 0. I think we did a lot of problems, maybe 16. So today we're going to deal with infinity over infinity to see, what we can do for the, by using the L'Hopital's rules here. Okay, so now we said, okay, let's start with part A here. So the part A, this is the limit x approach to infinity and the natural log x and the square roots of x. Remember, right? So we talk about it in the practice set, number 1. When you do this, you always plug the C first, right? So the natural log x, when the x approach to infinity, what you have here, infinity. Square roots of x, so when you put the x here, what you have here is infinity. So you check it first. Then you say, oh, okay, now it's infinity over infinity. So I know this is indeterminate form. So I can use L'Hopital's rule to show us. So this is limit x approach to infinity. So the reason why we also mention in the practice set number 2, the L'Hopital's rule is easy because you take the derivative on the numerator and on the denominator separately, okay? So now the natural log x, this is kind of review what you learned in the calculus 1, the derivative part. So the natural log x, the derivative will be 1 over x. Then the square roots of x, right? So is the x of the 1/2. So when you take the derivative, will be the 1/2. Then x to the 1/2 minus 1. So this will be negative 1/2, right? Because the x to the 1/2 is x square roots, right? Square roots is x 1/2. Then you take the derivative is x 1/2, 1/2 minus 1, so give you the negative 1/2 here. Okay, so now in here you can simplify a little bit. So this is x approach to the infinity. Then these two flip over to the top, right? So this one's here, this x here go down. So to the denominator, so this is x to the negative 1/2, so will be the negative 1/2 times x here, right? So what happened to here? So in here, so here, this will be limit x approach to infinity. So 2, so maybe I will change this one. So it's not very clear. So this is negative 1/2. And so x then times 1/2. So this is x what? X 1/2, right? So now you have the limit approach to what? Approach to infinity. So what happened to here? This one approach to infinity. So when you have fractions, if the denominator approach to infinity, what is the whole thing's approach to? Approach to zeros here, right? So that's why I know for this limit, it will going to approach to 0. You know, for this type of problems, sometimes the student has trouble is because when you try to combine with the fractions, so you just need to be careful for that. Okay, so now let's take a look at part B here. So this is the limit x approach to infinities, and then this is x plus x squared, and this is 1 minus 2x squared. So as always, you check it, right? So this is you put the x into the infinity. What you have infinity. So this is the x into the infinity. What you have negative infinity, but the negative sign doesn't matter. You can just put it in the front, right? So this is infinity over infinities here. So we can use L'Hopital's rule, show us, we say, okay, so this will be limit x approach to infinity. So what is the derivative on the top is 1 plus 2x, right? Then the denominator, so this is 1 is a constant, so the derivative becomes 0. So 2, so this is negative 4 what? 4x. Now you plug into the infinity over infinity. Oh boy, here's this infinities, right? So this is still negative infinity. So that means, okay, we need to do the L'Hopital's rule one more time. So what is here? This is 2. That's negative 4 here, right? So now what is your answer? It's negative 1/2. So this is the limit for this problem here. Some people might ask, say, hey, this problem looks very, very familiar. Seems we did it before. Oh, yes, right? So this one's here, you can, use a different way to do it instead of do the L'Hopital's rule. So what you can do, you can say, I'm divided by, because the largest exponents here is 2, right? So I'm divided by x squared, both in the numerator and the denominator. So this will be 1 over x squared minus 2. So what is here is x over x squared, so it's 1 over x plus 1 here, right? Now, when you let the x approach to the infinity, so what happened to here? This is approach to 0, correct? Because this is 1 over x. This one is approach to 0. So in here, what is your answer? Negative 1/2. Yeah, see, they match is here. So in fact, you have two ways. You don't have to use L'Hopital's rule sometimes, but sometimes L'Hopital's rule is a little easier. So it depends, right? Okay, now let's take a look at part C here. The part C, this is the limit x approach to infinity. Then this is the natural log square roots of x and the x squared. So as we say, you always check when the x approach to infinity. What is this one approach to? Approach to infinity. What is x squared approach to? Approach to infinity. So I know, oh, okay, so I can use L'Hopital's rules. So now let's do this. I say, okay, let me simplify it a little bit. So this one's here, natural log square roots of 2, I can simplify to the 1/2 of the natural log, right? So because the square roots of 2 is x to the 1/2. Then by the exponents power rule for the natural log, you can put the natural log half here. The reason why I want to do that is because then 1/2 is just become constant, right? It's easier to deal with, then use a chain rule, those things, right? Okay, so now I can move the 1/2 here. Then let's take a look at the L'Hopital's rule. tell us what do we do? It's 1 over, so natural log is 1 over x, correct? Derivative. So what is here? This is 2 what? 2 of the x here, right? Okay, so now we can combine a little bit. So now in here, this is 1/2, then this is the limit x approach to infinity, and then this x is here going down, right? Okay, so this will be 1/2 to the x square. If you like, you can move this 1/2 to the front. So it's limit 1/4, 1 over x square. So what happens here? So when the x approach to infinity, what is the bottom approach to? Bottom approach to infinity. So when the bottom approach to infinity, so I know what is the whole thing approach to? The whole thing approach to zeros, right? So the limit for this problem is equal to zeros here. Okay, now let's do a part D here, right? So the part D, this is the limit x approach to infinity, then this is a natural log x, the whole thing square, and x here. Okay, so let's take a look at this one here. So as always, try to plug the infinity in there. So you will see this one is infinity to the squares, right? So stays infinity. This one is infinity. So now we can have infinity over infinity. So I'm going to use what? The L'Hopital's rule. I can deal with L'Hopital's rule. Okay, so some people might ask here, why I cannot move this to the front? And the reason why this is not inside the natural log, right? So this square is the whole natural log squares here. Okay, so now let's take a look here. The derivative at the bottom is simple, right? So it's 1. So the derivative on the top here, so this will be 2. Then you use the power rule. So then this is a natural log. So you have a 2 minus 1s, right? Then what you need to do here? You need to do chain rules, right? So what is chain rule of natural log? Is 1 over x. So now let's take a look here. Combine a little bit. And so these ones here can go to the bottoms, right? Because it's 1 over x. So this is x, then this is 2, then this is natural log x. So now let's try again, put the x into the infinity. What happened here? Infinity over infinity. Okay, so let's do the derivative one more time here. So this is the limit, x approach to infinity. So this is 2 times. So here's 1. So what happened here is 1 over x. So you can move the 2 outside. This is x approach to the infinity, 1 over x. So what is 1 over x here? This one approach to infinities, right? So 2 over infinity is equal to what? 0, right? So we know this number is approach to zeros here. Okay, so the reason why I put these two problems here, I just want to make sure you don't get confused with the natural log to the x square or the natural log x square is inside. They are different, right? Okay, so now let's do one more, and then we can kind of quit for this one here. We will leave the another 5 problems to the part 2 here, so we don't make the video too long here. Okay, so this is the limit x approach to infinity. This is the square roots of x, and this is e to the negative x over 2 here. Okay, so in order to do this type of the problems here, right? So what we can do, we can say this is a limit x approach to infinity. Then this is x. Then I move this one to the bottoms, right? So the negative exponents is to the denominator. And then you let the x approach to infinity. So this is infinity. And what happened here? So e to the infinity power is infinity. So I know this is infinity over infinity. So I can use the L'Hopital's rules. I said this limit x approach to infinity. Okay, so one more time, I think a lot of people, a lot of students always get confused when they take the square roots. Okay, square roots is 1/2. So it's 1/2 x to the 1/2 minus 1, right? So 1/2 minus 1 is negative 1/2. And then the exponential function is what? The derivative is by itself. Whoa, but don't forget what we need to do here. Hey, we need to do chain rules, right? So this is 1/2 here. Okay, so now we can simplify this a little bit. So this 1/2 and this 1/2 is good, they can cancel. So let's see here, this is limit x approach to infinity. This is x to the negative 1/2. Then this is x to the over 2. So if you simplify a little bit, so this is x to the infinity, and this is square root of ex, and then the x over 2 over 1. So when you approach to infinity, so this will be what? This is infinity times infinity is equal to infinity. So what is the whole thing approach to? Approach to 0. Okay, so I guess, this will be a good place. We are halfway through this practice. We have another 5 problems. We can practice on the part 2 here. As I mentioned before, the L'Hopital's rule is very handy, and it's a very easy rule. And sometimes the student have trouble is like when you take the derivative and then some, so how to combine them from the numerator to the denominator. That's the trouble part. Sometimes students, lose points because of that. Okay, so right now this is a good place to stop. So remember, so what do we do? Practicing, 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 right? That's a way to make you getting better in the math. So I'm looking forward to talk to you again and to finish the remaining 5 problems when the form is infinity over infinity here. Okay, so nice to talk to you, and have a good day.